So hello everyone. In this video, I am going to discuss about naive-based na classifier and how we can use it to build a machine learning application for spam classification, right? So the idea would be to use the bag of words na approach to classify emails as spam or ham. So we have a set of emails and we are going to divide it into the training and testing, right? So, and that training set, we are going to use that to learn a model. And that learned model will predict whether a certain email is spam or ham. So the bag of words approach treats a document or a text, or in this case, in the problem that we are going to solve is the email. It treats this text as a bag of words such that the order of the words are not considered, okay? And we only take note of the frequencies of the word or how many times did the word occur in this text, okay? So in this case, the word "it" has appeared 6 times in the message, or the word whimsical or satirical or adventure has appeared once in the text, right? So how can we use this bag of words approach to classify whether an email is spam or ham? So we are going to use this as the features or the input to our model, okay? So now, suppose we have a spam email. So we are going to check whether words like offer or Viagra or dear Mr. or Mrs. or URL is contained in the email. So I just want to mention that these words are commonly appearing in spam na messages. Okay, so oops, sorry. So the problem is that, let's say the email does contain a URL. However, it is not an indication. It is simply an indication, but not an evidence or a proof that it is indeed a spam na email. Okay, so a perspective to the spam or ham classification problem. So we can think of an email having the probabilities of it being spam or probability of it having some certain words. So let's say the probability that the email is spam may be denoted by P of C, and the probability that the email contains the word offer is P of D. And you can see here the intersection between these two probabilities is the joint probability of the email being spam and containing the word na offer. And you already are I already discussed the base rule in the previous video, wherein the probability of A given B is equivalent to the probability of B given A times P of A divided by P of B. So the P of A given B is the posterior na probability, or this is the probability that a hypothesis A is true given the evidence, okay? And the P of B given A is the likelihood or the probability of seeing the evidence B given that the hypothesis A is true. And the P of A and the P of B are independent probabilities. So P of A is the probability that the hypothesis is true even before some evidence, okay, or even before we have collected the data. And then the P of B is the probability of observing the evidence. So using this into our spam ham classification problem, wherein we use the C and D na variables to denote the probability of an email being spam and containing some words. So we have the probability of C given D equals P of D given C times the P of C divided by P of D. So if we can understand it better with this example. Okay, so what would be the probability that the email is spam given that the word offer appears in the email? So what we mean by this is our hypothesis is that the email is indeed spam, okay? And how can we prove that that hypothesis is true given that the evidence D is that the word offer appears in the email. Okay, and it is equivalent to the joint probability of the email being spam and containing the word offer divided by the P of D equals offer. So let me just change this one. This should be W. Oops. Okay. So essentially, this joint probability is equivalent to the probability of the word offer appearing given that it is a spam message times the probability of the spam divided by the probability of observing the evidence or observing that the word offer does appear in the document or the email. Okay, so going back to this example, so does the email contain these words? And so how can we determine that the word is spam or ham based on the other words that are present? So in the previous example, we only considered the occurrence of one evidence or one word in the example. Okay, so how can we extend the Bayes rule given multiple words or multiple features? So the good idea would be to predict P of C, or the P of C being spam or ham given a set of words W sub 1, W sub 2 until W sub n in the document. Okay, and then C is the class, which it could either be spam or ham. And sorry, and then the D is the features of a document or the email. So in this case, it would be the bag of. So we can then modify the previous Bayes rule, having the probability of the C given D, where D is a set of words W sub 1 to W sub n. So we simply replace D with a set of words, or in this case, the set of, or the bag of words. So what would be the probability of C being spam given this set of words? And what would be the probability of C being ham given this set of words? Okay, so